let's go over some sapling questions. This is Unit 4, Day 2, 5.2 in the textbook, assigned for 11/15, 11/16, 2022. For anybody that was struggling on this assignment, please watch and you can get some insight. For question 1, we have a four-sided die in a shape of a pyramid. Each face has 4 numbers on it. So, and what we're looking for is the trying to roll 2 times. Imagine rolling 2 four-sided dice, and they're recording the number that is showing on the base of each pyramid. So in this case here, we got a 4 and a 4. For instance, you would record a 4 if the die landed as shown in the figure. So we would like to give a probability model for this chance process. So if each side has 4 numbers on it, then you're looking for having 16 total possibilities. All right, you're gonna have 16 total possibilities because you're gonna roll it once and you're gonna roll it twice. So the combinations would be like 1, 1, 1, 2, 1, 3, 1, 4. So the first roll could be a 1, second roll could be a 1, but it also could be a 2, 3, or 4. And then you would repeat that process with the 2s. So you'd have 2, 1, 2, 2, 2, 3, 2, 4. And so on with the 3s, and so on with the 4s. So there's going to be 16 total. 16 total, okay? So what that's going to look like is the following. When we're talking about give a probability model for this chance process, each outcome has a probability of 1 in 16. Your sample space would be 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4, 4, 1, 4, 2, 1, 3, 4, 3, 1, 4. And each of the outcomes has a probability of 1/16 because these are the order matters. So 16 possibilities. For question 2, the same scenario. Let's read the question. Find the probability of A if event A is getting the sum of 5. So let's think about all our options here. We had the 1, 1, 1, 2, 1, 3, 1, 4, 2, 1, 2, 2, 2, 3, 2, 4. All the way to the 4s. All right, and sum of 5, sum means add. So we want to look at the ones that add to 5. And I'm looking at this one, 2 and 3, 3, 1, 3, 2. 4 and 1. And those look like all my possibilities. 4, 3, 6, 7. So that looks like to me it's going to be 4 out of 16, which is going to be 25%. So it'd be that. Question 3. Mr. Starnes and his wife have 6 grandchildren, Connor, Declan, Lucas, Piper, Sedona, and Zane. They have 2 extra tickets to a holiday show and will randomly select which 2 grandkids will get to see the show with them. Give a probability model for this chance process. Well, let's see. We got Connor and Declan. If we're going to have 2 tickets, each opportunity is going to have 2, but once Connor's been chosen, Connor's not going to be chosen again, right? So it's going to be Connor and Declan, Connor Lucas, Connor Piper, Connor Sedona, and Connor Zane. That's 5. But then, of course, you're going to have the one starting with Declan. We're not going to do Declan and Connor again. So 6, 7, 8, 9. And then with Lucas, that's going to be 10, 11, 12. And then finally, well, actually, a couple more. Piper is going to go to Zane and Sedona, 13, 14. And finally, Sedona and Zane have to be connected. So that's 15 total. So your sample space is going to be all of those different possible combinations. And it looks like, let's read through the Connor Declan, Connor Lucas, Connor Piper, Connor Sedona, Connor Zane, Declan Lucas, Declan Piper, Declan Sedona, Declan Zane, Lucas Piper, Lucas Sedona, Lucas Zane, Piper Sedona, Piper Zane, and Sedona Zane. That's going to be your answer right there. That's going to list all your different possibilities out. Okay. All right. Question 4 is going to have the same sample space. So I went ahead and kind of abbreviated to use the same sample space here to talk about it. And it says they will randomly select 2 grandkids to see the show with them. Find the probability that at least one of the girls, so Piper and Sedona are the girls, get to see the show. So if I look at my girls, we're talking about Piper and Sedona. So any ones with the P or the S, at least one. That's 2, Piper, Sedona, Piper, Sedona. Piper and Sedona are there together. And then Sedona and Zane here. So that's how many of those we have. We have 1, 2, 3, 4, 5, 6, 7, 8. So we should 8 out of the 15 have at least one girl. So that's going to be this one. And I led you astray. I missed one. Oh my goodness. Piper, right there, right in front of you. There's a Piper there. So that's actually going to be 9 out of the 15. Oh my goodness. I almost got the wrong one. So there you go. 9 out of the 15 have at least one girl. Whew. Question 5. Miss Tyson keeps a mystery box in her classroom. If a student meets expectations for behavior, he or she is allowed to draw a slip of paper without looking. The slips are all of equal size, are well mixed, and have the same name of a prize written on them. One of the prizes, extra homework, isn't very desirable. Shocking. Here's the probability model for the prizes a student can win. Is this a valid probability model? Why or why not? Well, first thing I'm going to do is add these up. So take a minute to add those up. You can see if they add to 1, then it's a valid probability model. And if these are all less than 1 and greater than 0, they're a valid probability model as well. So each of these numbers, let's see, that's going to be 65, 80, 95, 100. That's going to add to 1, so that checks the box. But also each is going to be between 0 and 1. So those are your options. Each is going to be adding to 1. So it is a valid probability model because each probability is between 0 and 1, and all the probabilities sum to 1. So that will be your answer on that one. All right, for question number 6, we want to know the same scenario. We want to calculate some probabilities, find the probability that a student does not win extra homework. So the extra homework is 0.05, so does not win would be 1 minus 0.05, or the sum of these, which is going to be 0.95. So the probability that does not win extra homework is going to be 0.95. Okay, question 7. Ms. Tyson keeps a mystery box in her classroom. Same scenario. What's the probability the student wins candy or a homework pass? So candy is this, 0.25. Homework pass is this. There's no overlap. So we're simply going to add those together. And that's going to give you 0.25 plus 0.15. That should be 0.4. Candy or homework pass should be 0.14. So 0.4. All right, question 8 is a similar situation. We have a table. In this case here, we have government information. We want to choose an American household at random and count the number of people it contains. Here's an assignment of the probabilities for the outcome. The probability of finding 3 people in a household is the same as the probability of finding 4 people. So we know these two are equal to each other. So what I'm going to do first is, knowing that these add to 1, then I'm going to add these 5 numbers up, and I'm going to subtract that from 1. So what do you get? Well, let's see, that's 25, 32, 30, 50, 7, 64, that's a 768. So it looks like it's going to be 1 minus all that would be 1 minus 0.68. And that's going to give you 0.32. And that's going to be what these two add to. So individually, they're going to be, since it says they're equal to each other, they're going to be 0.16 and 0.16. So now I know 3 and 4 are both 0.16. Let's answer the question. Find the probability that a chosen household contains more than 2 people. So more than 2 people would be really all of these. Now I didn't really need to split the 32s up because these two will combine to 32 anyway, and then you got to add the 0.07, 0.03, 0.01. So 0.32 plus 0.07 plus 0.03 plus 0.01, and that's going to give you 10, 11 plus 32. That's going to be 43, so 0.43, at least 2. More than 2, not at least 2. Question number 9, here we go. Choose a young adult age 25 to 29 at random. The probability is 0.13 that the person chosen did not complete high school. 0.29 that the person has a high school diploma but no further education, and 0.30 that the person has at least a bachelor's degree. So this is question number 9. What's the probability that a randomly chosen young adult has some education beyond high school but does not have a bachelor's degree? So let's break this down. The probability is 0.13 that the person did not complete high school. So the probability not high school is equal to 0.13. 0.29 that the person has a high school diploma but no further education. So the probability of just high school is going to be 0.29. And then 0.30, the person has at least a bachelor's degree. So probability bachelor's or higher is equal to 0.30. So what must be the probability that a randomly chosen young adult has some education beyond high school but does not have a bachelor degree? Well, that's not one of our options, but let's think about this from, I guess, a whole sample space, right? We got no, these are all separate, all right? These are mutually exclusive. So none of these Venn diagram circles will overlap. But if you look at all these options, you got this 0.13, you got this 0.29, and 0.30. Well, that's not everybody. Some people start college but don't finish it, right? And if you look at these, you got 0.13, you got 0.29, 0.3. Guys, those are not near 100%. In fact, 30 plus 30 is 60, 59, plus, let's see, 69, 72% is these. So the remaining is going to be 1 minus 72%, okay? That's going to go out here, and that's going to give you about, I don't know, 28% that maybe start college but don't finish it. So have some education beyond high school, but does not have a bachelor's degree. Some college, no degree, or maybe an associate's degree. That's how you want to do that problem. All right, question number 10. Choose a young adult, 25 to 29. Probability is 0.13 that the person chosen did not complete high school, 29% that the person that has a high school diploma but no further education, and 30% that the person has at least a bachelor's degree. And so in this scenario, we want to know the probability that the young adult completed high school. So let's look at the not complete. We know that that is going to be 0.13. So the probability of complete, that's the complement of it, right? That's going to be 1 minus 0.13. And so that's going to give you 0.87. So it's like not completing high school is completing high school. It's the complement. You can just take that and subtract from 100%, and that gives you 0.87. All right, for question number 11, it's kind of helpful to look at this table here. The no high school is, the people that did not complete high school is 0.13. Those that got a high school degree is 0.29. Those that got at least the bachelor's degree is 0.30. And then if you remember, I believe this was 28% of the remainder that had maybe a little bit of college, but we didn't really get a degree or anything like that. So what we're looking for is find the probability a young adult has further education beyond high school. Well, that's going to be the ones that are, let's see, where's high school here? So beyond high school, we're talking about anything with some college attached to it. So we have these two added together, and that's going to give you 0.58. So further education beyond high school is the bachelor's degree or more plus whatever's left over. Okay, question 12. Students in an urban school were curious about how many children regularly eat breakfast. They conducted a survey asking, do you eat breakfast on a regular basis? All 595 students in the school responded to the survey. The resulting data are shown in a two-way table. Suppose we select a student from the school at random. Define F as getting a female student and event B as getting a student who eats breakfast regularly. All right, so we want to find the probability of B with that little C. That is not B. So we want to find the probability of those who do not eat breakfast regularly. And so if you look at the ones that eat breakfast regularly, that's going to be 300 out of 95. So in this case, it's just going to be 295 out of 595. So we're not looking at any of the male-female breakdown. It's just 295 out of 595. And so that'll be this fraction here. So it's going to be 0.496. All right, here's number 13. This problem here is the same event, but we have different events or different things we're being asked. So F is getting a female student. Female, breakfast is regularly eat breakfast. We want to find F and not B. F and not B. So we look at the female and we look over here. And then we look at the not breakfast and we just find the overlap. And so that's going to be 165 out of 595. 165 out of 595. And so we're looking down there. All right, question number 14. Same scenario, we want to find the probability of F or BC. So remember the formula for F is, or for OR is going to be, let's just review that formula real quick, is going to be the sum of them minus the overlap. So in this case here, if you just kind of look at the total sum, we have 275 female and we have 295 not Bs. Now the overlap is going to be what they kind of meet, and that's going to be at that 165. So that's going to be the overlap. So the way that you're going to do that probability is you're going to do 275 over 595 plus 295 over 595. But then you're going to take away the 165 out of 595. And let's see, so you're going to add those together. And well, that's not on here. So what we're going to do instead is we're going to look at, I guess, the individual numbers that make that up. So the numbers that make up 275 are these two. And then the numbers that make up 295 are those two. And so those three numbers here are going to be what we could add to also get the same number. So 130 plus 165 plus 110, do not count the 165 twice. And it's going to give you, looks like up here, 0.681. All right, question 15. In one large city, 40% of all households own a dog, 32% own a cat, 18% own both. Suppose we randomly select a household. What's the probability that the household owns a dog or a cat? Again, or is going to be plus. But in this case here, we want to do that addition. Since these are not mutually exclusive, we're going to want to go ahead and subtract the overlap. So we want to subtract where they have in common. So if we're just kind of looking at the numbers here, 40% owns dog, we'll call that A. 32% own a cat, and both, that's going to be A and B. So we got the numbers right in front of us. 0.4 plus 0.32 minus 0.18. That's 72 minus 18, which is going to give you 54. Question 16. A recent census at a major university revealed that 60% of its students mainly used Macs. The rest mainly used PCs. At the time of the census, 67% of the school students were undergraduates. The rest were graduate students. In the census, 23% of respondents were graduate students and used a Mac as their main computer. Suppose we select a student at random from among those who were part of the census. Define events G is a graduate student and M primarily uses a Mac. Find the probability of G or M. Interpret this value in context. So the first thing we want to know is, what's the probability of a graduate student? Well, we don't have that because this is undergrad. So to get the graduate students, we're going to do 1 minus 0.67. And that's going to be 0.33. But then the probability of M is uses a Mac. We actually do have that. 60% of its students use the Mac. So that's going to be M right there. And we have this number, which is 23% were graduate students and used a Mac. So this is going to be your both. This is going to be your and. So we're going to do probability of G plus the probability of M minus the probability of G and M. So 93 minus 23 is going to be 70.7. That's your OR. Add them up, subtract the overlap. Okay, this is the same problem as before, question 17. But the question is wanting to know this question. Consider the event that a randomly selected student is an undergraduate student and primarily uses a PC. So is an undergraduate student and uses a PC. Well, the undergraduates are going to be not the graduates, right? So that's going to be the G with the little C complement symbol. And then PC is not the Mac. So that's going to be the M with the little complement symbol. And then we're going to use the intersection, the upside down U, okay? So this is going to be the same as the probability of that and that. So it's going to be both of those complements, but which one is it? Well, the non-graduates are the same as the undergraduates. That's 0.67. We already had that from the beginning. The Macs were 60%, so the probability of not Mac is going to be 1 minus 0.6. That's going to be 0.4. Now, as you can see, we're not going to, this is not an addition problem, all right? We can't add those numbers up because first, you're going to get over 1. Second, this is and, right? So we want to know the overlap. So we can't just simply throw that in a formula, okay? We got to look at the big picture here. And I'm really thinking a Venn diagram is going to be super helpful on this one. So let's draw that real quick. Okay, we have in here, we have the graduate students. In here, we got the MAC students. And remember here, this was 0.23. And what we're going to do for the MAC students is, the MAC students is going to be 60%, so 0.6 minus 0.23. So in that case here, that's going to be 0.37. So those are just MAC that are not graduates. And then the graduate students are going to be 33, 30, oops, I put 0.3, it's 0.33, 33% minus 0.23. So that's going to be what, 10. So let's interpret this. This 10% represents the graduate students that aren't using a Mac. This 37% represents the Mac users that are not graduate students. But then overall, there's going to be some numbers on the outside. If you add these together, that's your 33 plus 37. Now it's going to be 70. You might recall that 70% represents graduate or Mac users. So non-graduate and non-Mac users, that's going to be left over, right? So these add to 70%. So then this is going to be 1 minus 0.7. So it's going to be 0.3. So your answer is going to be 0.3. But we have 2 of them. The one that we want to pick is this one because and is that symbol. That's the intersection, not the union. This symbol is or. So we're not going to use that symbol there, so therefore it's going to be that answer. Tricky problem, but that's kind of how you want to think about that, okay? All right, here's question 18. In one large city, 40% of all households own a dog, 32% own a cat, 18% own both. Suppose we randomly select a household. Which Venn diagram correctly displays the outcomes of this chance process? Well, let's look at the Venn diagrams that are drawn, okay? If I look at my dogs, I got 22% and 18%. Now 18% is the both. That seems to match up, right? These two add to 0.4, so that's good. And then these two add to what? 18 plus 14, 32. And then if you look at all of these numbers, 0.22 plus 0.18 plus 0.14, those are going to add to 22 plus 18 is going to be 40, 54. So that leaves you with 1 minus 0.54. And that's going to be 0.46. Now, that's fine. I don't know where the heck this word birds come from, but you know that's not birds. This is going to be not dog and not cat. All right, it could be iguanas or whatever. So that word bird, this would be great except for the word bird in there. So you know it's going to have to be this one here, because this is just everything else. All right. And then in these ones, this one's, we don't have anything there. We don't have anything there. And you don't want to put the total, right? Because in this case here, that would be 58%. That's more than a state. And the same thing here, right? That's too much, right? And then that's too much, that's too much. So you don't want to put the totals on these parts of the circles. So it's going to be the this option right here. Okay, question number 19. We have the same scenario. We want to represent and find the probability dog and not cat. So that's that C means not. So what we're looking for here is we're trying to find the dogs that are only dogs, but also not cat. So it's that 22%. Again, we can calculate that by just basically taking that 40% and subtracting the both. And that's going to give you 0.22. So the dog and not cat, 0.22. Okay, question 20. Suppose A and B are two events such that probability of A equals 0.3, probability of B equals 0.4, probability of A or B is 0.58. Find the probability of A and B. So basic formula, A or B is always going to be equal to the probability of A plus the probability of B minus the probability of A and B. So let's plug in what we have. 0.3 plus 0.4, and we have 0.58, that's going to go over here. And we'll just call that X. So 0.58 equals 0.7 minus X. Let's move the X over and subtract. So X is going to be 0.7 minus 0.58. Oh, it's going to give us about 0.12. So the probability of A and B is 0.12. A little algebra there for you. All right, question 21. The partially completed table shows the distribution of the 2016 AP Statistics exam. Suppose we randomly select a student who took the exam. So we're looking at about 23.5% got level 1, 15.5% level 2, level 3, 24.9%, level 4, 21.7%. And of course, you know, these are all going to add to 1. So let's add these together and subtract from 1 first. Do that. I'm going to pause the video because that's not mental math for me. All right, so I cheated. No, you can do this. Your calculator active on everything. So yeah, add them together, subtract from 1, you get 0.144. So I'm just going to write that in there. Now I can answer the question. Find the probability that he or she earned a score of at least 3. Well, you know what to do. At least 3 is going to be these numbers. And now that I know that's 0.144, 0.249, 0.217, plus 0.144. Let's see, 5, 6. Let's see, 4. I don't know. It's going to be. Looks like it's going to be this 0.466 there, and we'll double check that on our end there. Nope, that's why we use a calculator. So it's actually 0.61. So add those together, and you're going to get 0.61. There you go, 21. In a sample of 275 students, 20 say they are vegetarians. Of the vegetarians, 9 eat both fish and eggs. 3 eat eggs but not fish, and 7 eat neither. Choose one of the vegetarians. What's the probability that the chosen student eats fish or eggs? Okay. Let's see. 75 students, 20 say they are vegetarians. Of the vegetarians, 9 eat both fish and eggs. So we're just talking about of the vegetarians. So ignore all that for a minute. This is your denominator. So of the vegetarians, 9 eat both fish and eggs. 3 eat eggs, but not fish. Venn diagram time. Fish, eggs, 9 eat both. 3 eat eggs, but not fish, so 3. And 7 eat neither, so that's going to go out here. 7 eats neither. So we want to know what's the probability of fish or eggs. So first thing I want to do is, my brain wants to get this number here. So 7 plus 9 plus 3, that's 12 plus 7. That's going to be what, 19. So that means there's going to be, out of those 20, there's going to be one in here that eats fish. And so if I want to know what's the probability that chosen to eats fish or eggs, I'm going to take my 1, my 9, and my 3, and I'm going to add them. And of course, we're doing this out of 20, so it's 10 plus 3. So it should be that one there. All right, 23, the most common bet in craps is the pass line. A pass line bettor wins immediately if either a 7 or an 11 comes up on the first row. This is called a natural. What's the probability that a natural does not occur? So 7 or an 11 come up on the first roll. So these are our outcomes. Gosh, we got a 7 or 11. These are, can't get them at the same time, so we don't have to worry about any overlaps. So 6 out of 36 plus 2 out of 36 is going to be what? An 8 out of 36. And then the probability that a natural does not occur. So this is going to be the probability of 7 or 11. So the probability of not 7 or 11 is equal to 1 minus 8 out of 36, which, let's just, think about it. There's 36 out of 36. That's your complete one. So just subtract 8 from that. And that's going to give you 28 out of 36. So that's going to be that one there. And our last question, number 24. If a player rolls a 2, 3, or 12, it's called a craps. What is the probability of getting craps or an even sum on a roll of the dice? So 2, 3, or 4 is called craps. What's the probability of getting craps or an even sum on the roll of the dice? All right, so 2, 3, or 12 are getting craps. So let's just look at those first. Now on those, we got 2, 3, or 12. So we got 1, 2, 1. So 2, 3, 4, 12. That's this. But then we also got to incorporate the even ones, right? So we got to also kind of factor in, well, we got other ones too. We got 4, 6, 8, and 10. Of course, I'm not going to count the 12 and the 2 again. So we have probability of even that are not craps. That's going to be 3 out of 36, 5 out of 36, another 5 out of 36, and another 3 out of 36. So if I combine all of these, that's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. So add those up and you get 20 total out of 36. And that's, my friends, how you do the assignment. Y'all, thanks for watching. I hope this was helpful. If you have any additional questions, let me know.